Okay, here is a refresher, because hopefully you're fresh about this, and this is going to be a refresher about the things you need to show when we are graphing trig equations. Okay, so there are three things that I'm going to be looking at when I grade your papers. So I want to see your axis, your x-axis labeled with 2 complete periods. Okay, and anything else you might need to do in between there. Labeling your y-axis with your midline. Okay, and then your maximum, your minimums, and your 0 points where your graph crosses that midline. Those are the things that I'm going to be looking for on every single one of your graphs to earn all the points. Right, your job is to convince me that you know what you're doing, and you do that by plotting all 3 of those things. So let's look at our first one. Find the attributes and then sketch. So the amplitude, hopefully the amplitude is easy for you. The amplitude is the number in front of your trig. The period is always a calculation. It's always 2 pi divided by your b value. So in this case, your b value is pi over 2. The period is always 2 pi divided by your b value, or 2 pi divided by pi over 2. Okay, now we have division by a fraction. Remember, we never divide by a fraction. Instead, we multiply by the reciprocal. So the reciprocal of pi over 2 is 2 over pi. So when we multiply this, we do 2 times 2 and pi divided by pi. So this has a period of 4. Okay, notice there's no parentheses. No parentheses means no phase shift. And notice there is, in fact, a minus 2. Minus 2, which means we have a vertical shift of down 2 units. Okay, we'll talk about the y-intercept and the range once we sketch our graph, and we can see what it looks like. So the first thing we want to do is put your period, which is 4, on your x-axis. So you go over however far you want, and you put a 4, and then 4 plus 4, the second period is going to end at 8. So that's 2 complete periods from 0 to 4 and from 4 to 8. Okay, remember we calculated your period here, which is why we wrote it down there. Okay, we're going to put in your vertical shift. We'll go 2 units down, so 2 tick marks, and then you put in a horizontally dashed line representing your midline, or your 2 unit down transformation. So now let's plot your zeros and your maxes and your mins. Okay, this is a sine graph. So sine starts at the origin / where the y-axis crosses your midline. Sine ends at its period at the same point, so on the midline. And sine is also 0 in the middle. So in other words, at 2, sine will also cross your midline. Okay, now the other points, it's a positive sign, which means it goes up to a maximum first of 3 units above your midline. So 1, 2, 3. So I have a positive 1 tick mark. Okay, so there is my first maximum. And then I have to go 3 units below your midline, so I make 3 tick marks going down. And the minimum is going to be in the middle of 2 and 4. So here is 1 complete cycle of sine to there. Okay, well, we need to do 2 complete cycles. So you put another 0 at 8 and then a 0 at 6 right in the middle, another maximum of 1 above the x-axis, and a minimum of 3 below your midline, right? So the max is 3 above the midline, the minimum is 3 below the midline, and you make your graph as smooth and curvy as you can. So now let's do the analysis. Where does it cross the y-axis? Well, it crosses the y-axis there at 0, -2. Okay, that's where it crosses the y-axis, and the range is from 1, 2, 3, 4, 5. This is -5 in the y to +1. So the range is from bracket -5 to positive 1 brackets. Now let's look at number 2. Okay, so let's do all the attributes that we can here from our given problem. We never look at the minus, right? So we still have an amplitude of 3. We'll calculate the period using this number, but not the x, right? We don't ever use the x when we're calculating a period. So if x over 4, we take away the x, that means it's 1 over 4. So our period is 2 pi divided by 1/4. And when we multiply by the reciprocal, that's 2 pi times 4 over 1, which has a period of 8 pi. So this graph has a period of 8 pi. Right? No parentheses, so no phase shifting there, and a vertical shift of 3 units up. Okay, so that's going to be your midline, right, when we come to our graph, which is what we're going to do right now. The first thing we do is we put in your period. So come over, I don't know how far, and put 8 pi. And then another period is another 8 pi. 8 plus 8 is 16 pi. So we first label your x-axis with 2 periods. So 8 pi and 16 pi. And now we do our vertical shift, so we have to make 3 tick marks in the positive y direction, and you put in your horizontally dashed line, representing your midline of y equals 3, right? That's the middle of your graph now. So our equation is a negative cosine graph. So where cosine would normally start in the positive 3 units above your midline, so this is where cosine would normally start if it were a positive cosine, but because it's negative cosine, it starts 3 units below your midline. So this one, a negative cosine, starts below your midline, whatever your amplitude is, so 3 units below the midline. Now cosine will end where it starts. So if it starts at a minimum, it's going to end at a minimum. So at 8 pi, cosine will be back to its minimum value. And exactly in the middle, or at 4 pi, cosine is going to be at a maximum, 3 units above your midline. Remember, everything happens in the middle. So in the middle of 2 minimums is a maximum. And in the middle of a min and a max is a 0, right, where it crosses your midline. So these are the 5 points that make up your cosine. Okay, so we make a smooth curve that connects these, right, to complete one cycle. And then we go ahead and we do a second cycle. So we have another minimum back at 16 pi. We have a maximum in the middle of 8 pi and 16 pi. And we have zeros in the middle of those. So to complete our 2 phases, our 2 periods, we're going to make a graph that looks like that. So now let's analyze. Where are your x-intercepts? Well, the first one's at the origin, so at 0. The next one is at 8 pi. The next one is at 16 pi. Okay? And then from here, you can just put dot, 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 right? Because we've established the pattern. But that's 8 times whatever number we're looking at times pi. So 8 times 1, 8 times 2, 8 times 3, and so on and so forth. Okay, so this would be the general way to write all of the intercepts. It's not necessary for you to do that. Okay, 0, we have a 0, 1, we have an 8 pi, and we have a 16 pi. Those are the ones that come from your graph. So those are the only ones that you need to do. Okay, the y-intercept, well, that was still the origin, 0, 0. That's where it crosses the origin. And our range is from 0 in the y to 6 in the y. Those are all of the things that we need to do our graph. Okay, let's look at our third graph. This one has a phase shift. It has parentheses. Oh, good. Amplitude of 2. Period of 2 pi divided by 1/4. which is 2 pi times 4 over 1, which is once again a period of 8 pi. Phase shift, since it's a plus, that means it's going to go to the left, pi over 2 units. And no vertical shift, there's no plus or minus afterwards. Okay, so we'll look at the x-intercepts and the y-intercepts and the range once we do a little sketch of our graph. Okay, so first we're going to sketch having no phase shift. Okay, so we're going to sketch 2 sine of 1/4 x. That's what we're going to sketch to begin with, and then we'll come back and we'll do our phase shift. So we have one period at 8 pi, another period of 16 pi. It has an amplitude of 2, so we'll put 2 units above and below your x-axis. Because it is a sine graph, it starts at the origin, it ends at the origin, and has a 0 in the middle. Okay, in the middle of that, it goes up to a max, and in the middle of your next zeros, it goes down to a min. Okay, so this is the graph of your sine, 2 sine of 1/4 x. So we're going to do this in a dashed line because this is not our final answer. This is the graph that's going to help us get to our final answer. So whenever you have a phase shift on your test, I want to see this, your original graph without the phase shift. So 2 sine of 1/4 x. So now let's look at our phase shift. We go left pi over 2 units. So how far do we have to go? Do not just go over an arbitrary amount anymore. This is based upon what we have already written in here. So the period is 8 pi, which means the middle is 4 pi. So every one of our tick marks right now is exactly 2 pi. Okay, every tick mark that we have on our graph represents 2 pi units. And I need to go pi over 2, so I need to go half of pi. So if I take half of this, that's 1 pi. So I have to go another half. In other words, pi over 2 equals 1/4 of my current tick mark. Okay, 1/4 of my current tick mark, and it's to the left. So I'm going to go to the left 1/4 of a tick mark for all of these points. Every point moves over just 1/4 of a tick mark. Okay, so this is what I'm looking for on your test, is to see how far you have gone over based upon your markings. Okay, so if you don't know what your markings mean, well, that means you don't know what it means, and I can't give you credit, right? My job is to judge your knowledge. So if you don't know what these things mean, then, well, you don't know what they mean. So here are your points in pink. Your pink graph will be your solid graph. Yours doesn't have to be pink, of course. It should be a solid graph, though, because your intermediate graph was dashed. So there's your final graph right there in pink. Okay, so hopefully this has been helpful, and your brain now remembers the things that you need to do and show in order to convince me that you know what you're doing when it comes to graphing sine and cosine.